here. Here this question is asking, consider the integrated circuit CS amplifier in figure P10.34 for the case IBIAS is equal to 100 microampere, Q1 and Q3 are matched, and Rsig is equal to 200 kilo ohm resistance. And for Q1, mnCox is 90 microampere per voltage square, VA is 12.8 voltage, W over L is equal to 100 micrometer per 1.6 micrometer, CGS is 0.2 picofarad, and CGD is 0.015 picofarad. And for Q2, VA is 19.2 voltage. Okay, and neglecting the effect of capacitance inevitably present at the output node, find the low frequency gain, the 3 decibel frequency FH, and the frequency of the zero, that's FZ. So we have to find out the gain and FH and FZ. That's the question is asking for. Now let's see how to do that. So first of all, in order to find the gain is nothing but AM. That is given by negative GMRL prime. So in order to calculate the gain, we need to know the transconductance, that is GM, and also we have to find out the RL prime. RL prime is nothing but the output resistance. Like since we have Q2 and Q1 facing out, the equivalent resistance is going to be the RL prime. So in order for that one to find that one, we had to find out the RO1 and RO2. Both of them are in parallel, so we had to find out the RO1, RO2 parallel, and that's going to be the RL prime. And for the GM, we know that GM is equal to 2 times the drain current over the overdrive voltage. Here they have provided the bias. IBIAS is the drain current, IBIAS, which is equal to ID, and that's equal to 100 microampere. So we have that one available, but we don't know the V over drive voltage. That's not provided to us, so we have to find that one out. We can find that one out using the current formula that is given by ID is the square law, that is ID is equal to half mnCox W over L VOV square W over L here. So if you look at that, we have to make sure all the values are available to us except VOV, then only we can find it. ID current is available to us 100 microampere, and then mnCox value is provided to us right here, 90 microampere per voltage square. W over L ratio also provided to us 100 micrometer per 1.6 micrometer. So only unknown variable is VOV. So from this one we can solve for VOV. So if you plug in all value, this is 100 micro, and this one is half times 90 micro, and then W over L ratio, this is 90 right here. This is 90 micro, and then W over L ratio is nothing but 100 micro over 1.6 micro, and then VOV square is the unknown. That's what we are trying to find. So we have to just rearrange and solve for VOV, and if you solve for it, you will end up getting VOV to be 0.188 voltage. So this is our VOV value. Once we have the VOV value found out, we can find out the transconductance. That is GM is equal to 2ID over VOV. GM is equal to 2ID divided by overdrive voltage, and here 2 times the ID current is 100 microampere, and then overdrive voltage we just found out, that is 0.188 voltage. 0.188. Plug it all in and find the transconductance. That will give you 1.06 milliampere per voltage. So once we have the GM, we can find out the gain, because we know the gain. We are finding all this because we want to find out the gain. And we had to find another thing as well. We had to find the RL prime. We just solved for the GM. We still have to find out the RL prime. So let's find that one first. The RL prime is nothing but the equivalent output resistance. So here we have Q1 and Q2. The output resistance that's going to have is RO1 and RO2, and these two are parallel. So the RL prime is going to be RO1 parallel to, you can say RO1 here, RO1 parallel to RO2. Okay, so here let's find out the RO1 and RO2. RO1 is nothing but the early voltage divided by the ID current. Okay, and for the NMOS, here we have early voltage for the NMOS and PMOS. Q1 is an NMOS. For that one, the early voltage is 12.8 voltage. Q2 is a PMOS. For that one, the early voltage provided was 9.2 voltage. But the ID current is same. So same ID current, but the VA values are different. So it's going to have a different values for each of them. So RO1 is NMOS. So we are going to have VA over the ID current. That is VA is 12.8 voltage. And the current is 100 microampere. So if you plug it in and solve for RO1, you will end up getting 128 kilo ohm resistance. And RO2 is nothing but VA absolute value divided by ID, because we put the absolute value for the PMOS, and that one provided to us here is 19.2 voltage. 19.2 divided by 100 micro, and if you calculate that one, that will give you 192 kilo ohm resistance. Okay, now we have RO1 and RO2, so we can find out the RL. RL is nothing but these two are parallel, so 128 kilo parallel to 192 kilo. And when we have two resistors in parallel, the equivalent resistance is product over sum. You have to multiply and add in the denominator. And if you do that, you will end up getting RL to be 76.8 kilo ohm resistance. Okay, so once you have RL prime, now we can find out the gain. We are doing all this to find out the gain, because gain is given by negative GM RL prime. We have to find out the transconductance and also the RL prime. We found out both of them. We found out the transconductance right here, and we just find out the RL prime right here. So we have to plug it both in the equation AM and find out the gain. And AM is given by negative GMRL prime, and negative, the transconductance we found out is 1.06 milli, and the resistance we found out is equivalent resistance we found out is 76.8 kilo ohm resistance. Kilo, let's just put the kilo. So milli and kilo cancels each other, and then we are just multiply straightly. If you multiply, you will end up getting negative 81.4 voltage per voltage, and this is our gain. Once we have the gain, we can go for the next one. Next one is we have to find out the low frequency gain. That is low frequency gain is AM we found out, and then we have to find out the 3 decibel frequency FH. Okay, we have to find out the FH, and in order to find the FH, you have to know the equation. FH is given by 1 over 2 phi C in Rsig. We have to see if all the values are already available. As I see, Rsig is readily available, but we don't have the Cn provided, so we have to calculate the Cn. Let me use a different color, okay, to differentiate the first and second. So Cn, this is what we have to calculate. To find out the Cn, the equation is CGS plus CGD times 1 plus GMRL prime. Okay, and CGS is provided in the question, which is 0.2 picofarad, 0.2 pico, and then CGD is provided to us as well, 0.015 pico, 0.015 pico, and then 1 plus GMRL prime. Here we have negative GMRL prime. Here we had to put GMRL prime, that is the positive value of it, that's 81.4. Okay, plug it all in and calculate the Cn value. You will end up getting 1.43 picofarad. Okay, once you have the Cn value, then we can find out the FH frequency. Again, let's put the equation again. FH is nothing but 1/2 C in Rsig. 1/2 times C in times the Rsig. And here 1/2 the C in value we just calculated that to be 1.43 picofarad. 1.43 pico, and then Rsig value we just calculated. Rsig's value is provided to us, that is in the question 200 kilo ohm resistance. So 200k right here, and solve for this one. You will end up getting 556.4 kilohertz. And once you have FH value, we can find out the next one. The next one is asking find the frequency of Fc, zero frequency, that's Fz. For that one we have a different equation, that is Fc is equal to Gm over 2 phi times Cgd. For this one all their values are readily available because we already found out the transconductance, that is right here, 1.06 milli, and then times 2 phi, and then Cgd values provided to us in the question, that is 0.015 pico. So once we have plugged the values, we will end up getting the final value to be 1.12 times 10 to the power of 10 hertz. Okay, and that's it for this question. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.